Hi guys, in the given question there is a vessel given to us which is in the form of an inverted cone. The dimensions are known. The vessel is completely filled with water up to the brim. Now lead shots which are in the shape of a sphere are dropped inside this vessel and 1/4 of the water flows out. We have to find the number of lead shots dropped inside this vessel. So let's say this is our vessel which is in the shape of an inverted cone. Its height is equal to This height is equal to 8 centimeters, and the radius which is open from the top, the radius of this circular top, that's equal to 5 centimeters. Now it's completely filled with water. The vessel is completely filled with water. So let's say this is water inside this vessel, conical vessel. So first of all, what I'm going to do over here, I'm going to calculate the volume of water which we have. So the volume of water you will see that would be equal to, because the vessel is completely filled with water, volume of water that would be equal to the volume of this vessel which is in the shape of a cone. So it would be equal to volume of cone. Now when lead shots are dropped inside this vessel, these are the lead shots. Let's say we have n number of lead shots. These lead shots are spherical in shape. When these n lead shots are dropped inside this vessel, 25% of the water flows out of the vessel. So if you look at this over here, the volume of water flowing out of the vessel, that would be equal to what? The volume of these n spherical lead shots. The volume of water flowing outside the vessel would be equal to the volume of these n spherical lead shots. So we can write volume of these n spherical lead shots would be equal to 25% of, since 25% of volume of water flows out, 1/4 of the volume of water flows out. So 25% of volume of water, and volume of water, that was nothing but equal to the volume of cone. So we can write the volume of these n spherical lead shots is equal to 1/4 the volume of this cone. Now we know dimensions for all of them. The radius of the n spherical lead shots, let's call this radius, the radius of the cone, as R1. The radius of the spherical shots, that's equal to R2, which is equal to 0.5 centimeters. Now let's come back to our equation over here. Volume of n spherical lead shots, that would be equal to n into 4/3 pi R2 cube. Volume of any sphere, that's equal to 4/3 pi R cube. So volume of n spherical lead shots, that would be n into 4/3 pi R2 cube. That's equal to 1/4 into the volume of any cone, that's equal to 1/3 pi radius of the cone that we have taken as R1, 1/3 pi R1 square into h. Now from this equation we need to calculate the value of n. N is the only unknown which we have over here. Let's substitute all the values. So it would be equal to n into 4/3 pi. Pi we can cancel out from both sides. Pi n into 4/3 into R2 cube. R2 is 0.5 centimeters. So 0.5 cube, that's equal to 1/4 into 1/3 into R1 square. R1, that's equal to 5 centimeters over here. So 5 square. And the height of this cone, that's equal to 8 centimeters into 8. So the value of n which you will get from this, let's cancel out this 1/3 as well. So n, that would be equal to 1/4 into 5 square into 8 divided by 0.5 cube into 4. If you calculate this value, guys, the value of n you will get, that would come out to be 100. Yes, there are exactly 100 spherical shots which are dropped inside this vessel. The value of n, that's equal to 100. So if we drop 100 spherical shots inside this conical vessel, you will see 25% of the water, 1/4 of the water that would flow out of this vessel.